This is Calculus, Chapter 5, Section 2. So this section is actually kind of a lengthy one. So I went ahead and went through and broke it up into 3 different sections. So the thing is with this, there's a lot of information, and a lot of it is going to be different types of notation and working with math stuff that you guys may have never done before. So I broke it up into the separate sections just so that we can get a practice of some of the basics first before we get into actually applying it. So the first of these basics that we're going to be taking a look at here is something called sigma notation and summations. So here it says for sigma notation, it's the sum of n terms, a sub 1, a sub 2, a sub 3, all the way out to a sub n. So here, in terms, this little sub 1, sub 2, sub 3 just represents the first term, the second term, the third term, all the way out to the nth term. And this is how we're going to write it. The first thing here is going to be a sigma notation, and some of you may already know what a sigma notation or a sigma looks like. But if you possibly don't, take a second, pay attention to how I'm going to draw this. It's going to look like this. Sometimes mine look pretty neat. Sometimes they look pretty squished and, not very well put together. Mine tend to be a little flatter. Here you can see actually in the examples, here's some sigma symbols that are actually a lot taller than the one that I've got. As long as you're close, you're going to be okay. And then on the bottom, it's going to say, for this one, I equals 1, and on the top is n. So what that means is from I equals 1 to n of a sub I. So what this is telling you to do is, first off, this I equals 1 and this n on top means that you're supposed to plug numbers into I, starting at 1 all the way to n. So it would be an a sub 1 and then an a sub 2 and then an a sub 3 all the way up to an a sub n. Sigma here signifies that they want you to take the sum. So we're going to plug in not only 1 through n, but then we're going to add them along the way. So this becomes an a sub 1 plus an a sub 2 plus an a sub 3 plus all the way out to an a sub n. So that's what sigma notation looks like. That's what it stands for. Here, the I, that thing is called the index of summation. So I is the index of summation. This here, double check your notes. Yours might say a sub 1. It's supposed to say a sub I. So a sub I is the ith term of the sum, just meaning that whatever this small subscript number is, that's what number term it is in that sum. So when I say a sub 3, here's a sub 3, it's the 1, 2, third term in the sequence or in the sum. The upper and lower bounds of the summation are n and I. So lower bound I, upper bound n. So the first thing we're going to do is we're just going to go through practicing expanding these things to see exactly what it is that they mean before we actually then go in and try to find any of these actual summations. So for this first one, part A is the summation from I equals 1 to 6 of I. So basically all we are doing is we are plugging in the numbers 1, 2, 3, 4, 5, and 6 into I. So it would be a 1, and then plus plugging in a 2, plus plug in a 3, plus plug in a 4, plus a 5, plus a 6. We're not actually solving anything, we're just expanding it, so that problem's done. For B, we're taking the summation from I equals 0 to 5 of I plus 1. So with this one, and if we write it out long, first we're plugging in a 0, so it becomes 0 plus 1. Then we're going to plug in a 1, so 1 plus 1. Then we're going to plug in a 2, so 2 plus 1. Then a 3, which is 3 plus 1. Then a 4, so 4 plus 1. And then a 5, which is going to look like a 5 plus 1. All right, now, so each of these, what we can do then is go in and actually simplify inside each one of these parentheses 0 plus 1 is 1, 1 and 1 is 2, 2 and 1 is 3, 3 and 1 is 4, 4 and 1 is 5, and 5 and 1 is 6. So really what this is showing you is that you can end up with the exact same sum with your summation notation here expressed a little bit differently. So because I ended up starting one lower, by adding one here, I ended up with the exact same thing. All right, on the next one, part C, this one's going to look a little bit different just simply because instead of going to an upper limit of an actual number, this one's going to an upper limit of just an n. So when we're expanding these right now, when they just say to expand it, what we're going to do is go ahead and plug in a couple of them and see what it looks like. So first we're going to start, and be careful here, it's not into the n's, it's just into the i's. So into the i's, first I'm going to plug in a 1. So that would be a 1 over n, and then a 1 squared plus 1. Then I'm going to plug in a 2. So that would be a 2 over n times 2 squared plus 1. Then I'll go ahead and plug in a 3. So 3 over n times 3 squared plus 1. And then I would continue to do that all the way out to plugging in an n. So if I plug an n into all the i's, I get an n over n times n squared plus 1. Now we could on this one go through and do a bit of simplifying. It's not necessary to do that on here, but you could go in and say that this is really a 2, and the 2 times the 1 over n would actually be a 2 over n. Here this 2 squared would make a 4, 4 plus 1 is 5, 5 times 2 is 10, so that's really a 10 over n. Here 3 squared is 9, 9 and 1 is 10, 10 times 3 is 30, so that's a 30 over n. All the way out to here, an n over n is just a 1, and then we've got our n squared plus 1. So you could do that, but really it's okay, perfectly okay just to stop right here. And the last one for expanding, this one we aren't going to n, but we are going to a really large number. So if we were to actually go through and write all of these numbers from 1 to 52, we would have this entire sheet just absolutely filled. So instead, whenever you do problems like this, what you can do is plug in the first 2 or 3. So if I plug in a 1, that would be a 1 squared plus 1. Plug in a 2 would make a 2 squared plus 2, because these are both i's. Plug in a 3, and I would get a 3 squared plus 3. And then what I can do is, instead of continuing on with all the numbers in the middle, I can put a plus dot, 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 and then go all the way out to the end. And the very last one is a 52, so a 52 squared plus 52. And I'm not going to, on this one, do any kind of simplifying. I'm going to leave it just exactly like that. The idea is just so that you can see what it is these things would expand to if I had to actually go through and find what all of it added together would be. Now, the thing on the back here is, instead of having to go through and figure out what all of these are going to end up being, we're going to get some formulas on the back that are going to help us figure out what these different things would be without having to do all the extra work. So here are our summation formulas. Oh, shoot, and this one didn't print right. This one should actually be over on the side, and I imagine that the paper that you guys have is probably that way. I had to print an extra copy. Oh, no, it's not. Yours looks just the same. All right, so we're going to run out of a little bit of room here at the bottom to write everything that I wanted to write, because this was supposed to be over here and not underneath, but that's okay. We can still work through this even with the way that it is. We've got 4 different formulas here. You are not going to be expected to memorize these 4 formulas. This is going to be something that you're going to get to have on a note card. Now, the only thing is you will be expected to know how to utilize these different formulas. So make sure you understand how to do them and what it means, but you're going to get to have this to look at in order to actually go through and solve the problems. All right, so this first one is the summation from 1 to n of a constant. What that is going to end up being is just whatever that constant is times the upper limit. So an example of this, and this is what I wanted to put underneath it, but we can't for this one because that's underneath. That would be like the summation from I equals 1, we'll just say to 7 of 5. Because there's no number to plug, or there's no i's to plug numbers into, the first term would be a 5, the second term would be a 5, the third one would be a 5, all the way up to 7. So we would just take 5 times 7, and that's how you would utilize that formula. For the next one, I equals 1 to n of just an I, that follows this formula here. So it's the upper limit times the upper limit plus 1 divided by 2. So an example for this one would be like the summation from I equals 1 to 8 of I. So that would be like taking 1 plus 2 plus 3 plus 4 plus 5 all the way up to 8. So if I use the formula, first it's just the n, which for this it's an 8, times n plus 1, so 1 more than that number, which is a 9, and then divided by 2. That formula there will give us what 1 plus 2 plus 3 plus 4 all the way out to 8 would be. The next one is if it's an I squared. So from I equals 1 to n of I squared, you take the upper limit times the upper limit plus 1 plus twice the upper limit plus 1 all over 6. So an example of this one, we could say the summation from I equals 1 to 4. So that would be like 1 squared plus 2 squared plus 3 squared plus 4 squared. And then yes, of I squared here. So using the formula, it's the upper limit, which is 4, times 1 more than the upper limit, which is 5, times double the upper limit plus 1. So double 4 is 8, plus 1 more is 9, all over 6. So if we multiply and divide, that's going to tell us what 1 squared plus 2 squared plus 3 squared plus 4 squared would be. And the last one we're going to look at is a cube. So if you have summation from I equals 1 to n of an I cubed, it's the upper limit squared plus 1 more than the upper limit squared, all divided by 4. So an example for this one would be I equals 1, and we'll choose a big one this time. We'll go up to 57 of I cubed. So that would be like 1 cubed plus 2 cubed plus 3 cubed, all the way up to 57 cubed. And if we follow the formula, it's the upper limit squared, so 57 squared, times 1 more than the upper limit squared, so times 58 squared, all over 4. So on these last 3 examples, we are going to use those formulas to actually evaluate these sums, figure out what they would equal without having to actually go through and do all of the long math to get there. All right, so the first one here. The first one is the summation from I equals 1 to 10 of I plus 1 over n squared. Now, when you do these, first thing, you can take out any n's and pull them outside, because it's not the n's that are going to be changing each time, it's the I that changes each time. So I could think of this as a 1 over n squared times the summation of I equals 1 to 10 of I plus 1. Then I can take this just like we've done with our limits and like we've done with our derivatives and last class period with our integrals. The sum of a, well, the summation of a sum is the sum of the summations. So that means I can take 1 over n squared times, and then I can sum each of these individually. So this would be the summation from I equals 1 to 10 of I, plus the summation of I equals 1 to 10 of 1. And now each one of these, this one here is going to end up following the rule that we had up here for the summation of I equals 1 to n of I. So this one uses the formula n times n plus 1 over 2. So this one is going to be n times n plus 1 all over 2. This second piece here, that one's just a constant. So that one's going to follow the constant rule, which was the first one here, which says it's just a constant times n. The constant on this problem is a 1, so that's going to end up being just a 1 times n. And now with this, there is still this 1 over n squared in front. And then we're going to work with this here. Now, our n is a 10. So at this point, we could just plug a 10 into all of our n's and come up with an answer. But before we do that, what I want to do with this problem is go through and simplify it, because we're going to run into problems starting next class period and the following, where we don't want to actually just plug straight in. We're going to want to end up with formulas that we could plug any n into here, and it would give us what the sum would be. So same formula part here, I plus 1 over n squared, but maybe we wanted to go to 100 instead of 10, or maybe we wanted to just go to 57. That's going to give us a formula that all we'd have to do is plug in a 57 or plug in a 100, a much more simplified formula than just this. So we're going to go through and simplify here, and the first thing that we can do is we can distribute the n. So this last part here is nothing but a bunch of algebra, which some of you may or may not like, but if you don't like it, that probably just means that you need a little bit more practice with it. So n times n is n squared. N times 1 is plus n over 2. I'm not going to write this as a 1n anymore. I'm just going to put an n. Now here, if I find a common denominator, the common denominator would be a 2. So here's my 1 over n squared still here. I'm going to have an n squared plus n because that's already over 2. I don't have to multiply it by anything. But this n needs to be multiplied by a 2 over 2 to get a common denominator. So that's going to make that a 2n. And now over that common denominator of 2. Next thing I'm going to do is combine like terms. So I have a 1 over n squared. Here I've got an n and a 2n that will combine to make a 3n. Well, my thing's not wanting to focus in. Give it 1 second. Keeps going out of focus. What is going on? I'm going to pause the video and see if I can't get it to focus. All right, I think I got it. Okay, so I'm combining like terms here to turn that into a 3n. So I have an n squared plus 3n over 2. Now what I'm going to do is, even though I just put it all together, I'm going to go ahead and break it back apart so that it becomes a 1 over n squared. This is an n squared over 2, and this is a 3n over 2. Because now what I'm going to do is take that 1 over n that I have on the outside, and I'm going to go ahead and distribute that to the inside, so that this n squared ends up going to the denominators. So this would be an n squared over 2n squared, and this would be a 3n over 2n squared. Now I'm going to reduce here. The n squared's reduced to leave just a 1/2. Here an n will reduce to leave a 3 on top and a 2n on bottom. So plus 3 over 2n. So now at this point, that's going to be our simplified formula if we wanted to go through and figure out what this would be for any value of n. But for this particular problem, our n equals 10. So we're going to plug in and make that a 1/2 plus 3 over 2 times 10, which would be 1/2 plus 3 over 20. If I found a common denominator, that would be a 10 over 20 plus a 3 over 20 to make a 13 over 20. And then that's going to be our final answer, which, want to point out, yes, we would have ended up with the exact same thing had we stopped way up here and just gone ahead and plugged in a 10 for all of the n's, but we're going to need later on in the section to learn how to simplify all of it down. So I want you guys to start getting into the practice now of doing all of your simplifying with your n's. All right, part B. Part B, we're summing from I equals 1 to 100 of I plus 1 over n squared. So we are going to, again, with this n squared, take it and pull it on the outside. Oh, I take back. Here's why we did all of our simplifying. This is the exact same problem we had before. So now that we actually have our simplified version down here, all I have to do is change what I plugged in. So I know that all of that summation simplifies down to a 1/2 plus 3 over 2n, and this time our n equals 100 because our upper limit changed from a 10 to a 100. Therefore, this is going to be a 1 over 2 plus 3 over 2 times 100. 2 times 100 is 200, so that'd be 3 over 200. Common denominator would make that 100 over 200 plus 3 over 200 is going to give us 103 over 200. And if you can't do that common denominator stuff in your head, you can always plug it in your calculator. All right, so now the last one, part C. This one, don't get tripped up because they're calling it a K instead of an I. Sometimes they'll do that and change this bottom number here. We're still going from our lower limit to our upper limit. It's just now instead of plugging in for I's, we're plugging into these K's. Now with this, we don't have any type of rule that says that we can do any kind of product. So the first thing that we're going to have to do is distribute that K so that we end up having something that more closely resembles the rules that we have at the top of the page. So that's going to end up being the summation from K equals 1 to 6. When I distribute, it's going to make it a K squared and then plus a 2K. And now I can break each of these up to make the summation from K equals 1 to 6 of K squared plus the summation of K equals 1 to 6 of 2K. And now the only other thing that I'm going to do before I go in and start doing my substitutions with my formulas is I don't have a substitution that involves a variable here. So I'm going to take, I'm sorry, not a variable, a constant that involves this constant here. So I'm going to take the 2 and bring it on the outside so that we just have the K on the inside. Just like we were able to over here bring out that 1 over n because we knew it was just a constant, this 2 is just a constant. We can take it out the same. So K equals 1 to 6 of K squared, the first one didn't change, plus 2 times the summation of K equals 1 to 6 of K. And now we're going to go through and do our substitutions. So first off, this one here is using that K squared or I squared formula. And if we go back up to the top here, I squared is n times the quantity n plus 1 times the quantity 2n plus 1 all over 6. So it is n times n plus 1 times 2n plus 1 all over 6. And then the second one, this here, first off, the 2 is just going to transfer. So I'm going to have a 2 times. And now the formula for just a k or just an I is n times the quantity n plus 1 all over 2. So this is n times n plus 1 all over 2. And again, at this point, we could just plug in that n equals 6 because that's our upper limit. But instead, what we're going to do is we're going to go through and do our simplifying. That way we have a formula should that 6 ever change to any other type of number. So here I'm going to do some distributing. First, I'm going to distribute with these two binomials. I'm going to leave the n on the outside momentarily. So n times n, 2n, sorry, is a 2n squared. Here I'm going to have an n times 1 to make an n. Here I'm going to have a 1 times 2n to make a 2n, and a 2n and an n is going to make a 3n. And a 1 times a 1 is a 1. All over that 6. Over here, I have a 2 on the top and a 2 on the bottom. I can cancel those 2's, and I can distribute that n to make a plus an n squared plus n. Then I'm going to distribute this n. So it becomes 2n cubed plus 3n squared plus n all over 6 plus n squared plus n. Next thing I'm going to do is I'm going to go through and find a common denominator, which means that n squared and that plus n need to be over 6 as well, which means I have to multiply both of these by a 6. So I'm going to have a 2n cubed plus a 3n squared plus an n. That one gets times 6, so plus 6n squared. That one gets times 6, so plus 6n. Now all of it is over a 6. Then I'm going to combine like terms. I don't have any other n cubes, so it's just 2n cubed. I have an n squared and an n squared. The 3 and the 6 are going to make a 9n squared. And then I have an n and a 6n to make a 7n. All over 6. And then the last thing I'm going to do, even though we put it all together, I am going to go back now and take it all apart. So this is going to be a 2 over 6, which is going to be a 1/3 n cubed, or an n cubed over 3. Here the 9 and the 6 are going to reduce to a 3 and a 2, so 3n squared over 2. And here the 7 and the 6 won't reduce, so it's just a 7n over 6. So that would be the formula I would use if I had any number of for my upper limit. But for this one in particular, because my n was 6, so just a reminder up here, my upper limit here was 6, I'm going to plug in a 6 for all of these n's. So this would be 6 cubed over 3 plus 3 times 6 squared over 2 plus 7 times 6 over 6. And if we punch all that in the calculator, we end up with 133. All right, so you guys need to go through and practice just the problems here on this first part of section 5.2. So you can do on page 299, this is numbers 1 to 23 all odd, or here I've got them all written out for you to practice. But just like I said on the last lesson, you guys need to actually get in here and practice these homework problems so that you start to get better at doing these summations. You're going to need to know how to do these. Ask any questions that you have next class period, because we're going to keep building upon this, and it will get immensely harder in the future if you're not caught up and able to do these skills here at the beginning.